another type of functions, the final one, trigonometric functions. So they involve a study of angles. So I first want to discuss some basics. And what is the basics? Well, let us again draw a picture with a circle, sort of circle. Okay, now let us recall what angles we can have. So we always, positive angle is always counterclockwise, so 90 degrees plus 90 degrees is counterclockwise angle. So if we go with the clock, then we get minus 90 degrees, and we have 180 degrees to be this angle, 270 is this one, and 360 is a full round. And again, minus 180 is half a round the other way around, and so on. Now, in general, we do not work so much with angles in centigrades, but with radians. And to this end, I want to draw a circle with radius 1. So we put 1 over here, and we have this circle. Now, what is the length of this circle? This is the perimeter. With a circle of radius 1, it is 2 times the radius is 2 times pi is 2 times pi. So the length of this chord is 2 pi. So the length of half it is pi, equals pi. And length of a quarter of it is pi over 2. Length of half of it is pi. Length of 3/4 is 3 pi over 2, and the length of the full chord is 2 pi, as I said before. So it's not necessary to draw it, but for completeness I will do it. 2 pi. So we can connect angles with the length of the chord, with the length of the chord around the circle of radius 1. And so we get this relation. The following happens that pi over 2 corresponds to an angle of 90 degrees. Now if we go an angle with the clock, then we say that minus pi over 2 is the angle minus 90 degrees. So minus pi over 2 is connected to an angle of 90 degrees with the clock. And so on. We can connect pi to 180 degrees, 3 pi over 2 is then 270 degrees, and so on. 2 pi is 360 degrees, 4 pi is 720 degrees, and so on. So with each angle of x degrees, we can connect a multiple of some coefficient times pi. Well, since pi is 180 degrees, x degrees is x over 180 times 180 degrees. 180 degrees is pi, so we get x over 180 times pi. So there's a connection between the amount of degrees and the factor in front of pi. So instead of angles in centigrades, we will now speak about angles in radians, so called pi. This notation we call radians. Okay, most of you know this quite well, I suppose. Now there are a number of identities which are very useful to recall. So this is not only about radians, but about the sum of angles in a triangle. So I have the angle alpha, beta and gamma in a triangle. The sum of the angles is equal to 180 degrees if you speak about degrees, and if you speak about radians it is equal to pi. Now we have the Pythagorean identity. So if we have a triangle with one angle of 90 degrees, which is denoted by this, so this is an angle of 90 degrees or pi over 2 radians. Then if we look at the length of the corresponding sides, A, B and C, then we know that the Pythagorean identity tells us that the sum of the squares a squared plus b squared is equal to the squared of this side. The last thing about calculation, since we're going to calculate with squares, is the following relation. In Dutch it's called a merkwaardig product. In English I do not know whether it has such a curious name. So the square difference of two squares, the squares a squared minus b squared, is equal to the difference a minus b multiplied by the sum a plus b. So these are some basic facts that we have to know to start to speak about trigonometric functions.